Okay. So far we took ventilation as constant, CV was constant. Now, if CV is varying with time, then you can't explicitly find out the temperature swing. So far we found out explicitly, every time explicitly we found out the temperature swing above the mean inside temperature, but if ventilation is varying, then you can't find out. So, variable ventilation, then we have a little bit of. So, what we can assume is we can write that there are two components of the heat flow, there are two components of the heat flow. One is a mean steady part, another is a fluctuating part, and we could write it as AU CV into Ti minus TO bar, that is how we wrote it, and this we wrote as AY CV Ti swing, right. Now, see if CV is, CV is constant, I mean CV was constant here. So, we will now vary CV as a function of time. Now, before I do that, supposing it is a function of time, then I will have a product of CV t, CV that is a function of time, and Ti t as well. Now, you see this there is a product, and you cannot find out Ti t explicitly. Coefficient of Ti t will be a function of time, there will be 24 coefficients. Here there is Ti t, this is constant. So, you can explicitly find out, take everything on the left hand side, divide by this, then you are finding out Ti swing, this component you can find out. But supposing CV is also a function of time, then for each time you will get one equation. For each time, supposing CV is a function of time, CV t. So, this becomes CV t multiplied by Ti t. So, for each time I get one equation, I will get 24 equations, and I got to solve those 24 equations to find out the swing. But there is another problem, even the mean delta t, that I may have to find out together. So, basically I will have 25 equations to be solved to find out, it is a matrix. So, solve inverse the matrix to get it, not very difficult because very much sparse matrix, a lot of zeros would be there. So, we will see that. So, what we define is we define Qxt as sum of these two, Qxt. Anyway, this is not a function of time because this mean constant, this is a function of time. So, Qxt is something like this, and Qxt is something like this. So, Qxt is this plus this AUTO, right, and CV is now a function of time. So, I am separating this out, AYTIT, and CV is a function of time. So, I write it like TIT, and from here this CV TIT I have taken out this side. So, you can see that it is AU TIT bar, AY TIT swing, this is what I have written, and CV part I have taken separately because CV is a function of time now. So, CVT, and this is also taken into account because this is a function of time, this is also a function of time. So, it is written like this. So, if I write like this, what is this? This is nothing but I call it delta T bar. That is the temperature difference between inside and outside mean. So, this is also an unknown for this one because unless I know, earlier my CV was constant and therefore, I was able to find out an inside mean, but now CV is a function of time. So, I cannot find it out in straightforward manner. Ti, this will not be also known to me, this also will not be known to me, it is also an unknown. So, the 25th unknown is this. So, I have got 25 unknowns now, and I can write for each time an equation, I will get 24 equation. I have to add one more equation, and using 25th equation I will see that how we get it. I can solve those 25 equations to find out the difference in the mean and fluctuating component of inside temperature. In other words, 24 temperature inside swing, temperature swing inside plus 1 difference in mean I can find out and use that to find out the 24 hourly temperature. Let us see how do we do it, right. So, again we will solve an example also. So, if I 24 hours 24 equation can be written 25 unknowns as 24 of them plus delta t. Delta t is this, right, delta t is this. So, qxt is equals to au delta t au ti swing cv. This is how I can write the same equation. I am writing it in a slightly different manner, and for each time, because every hour I have got cv varying, number of air changes per hour is varying at every hour, hourly variations are there. So, therefore, I will get separate cv 24 cv and I can write this equation. So, 25th equation is in the question. I sum up all those 24 hourly qxt. If I sum up all those 24 hourly qxt, right, now what will happen? I will have sigma ay plus sum of tit, this term will come, sum of tit for I going from 1 to 24. What will be this value? Sum of fluctuations, sum of fluctuation for all 24 hours is equals to 0. So, if I put this equals to 0, that becomes the 25th equation, that becomes 25th equation, right. That is because if you the 25th independent equation, if I sum up two equations I get a third equation, that is not an independent equation, right, because that is what you so this once we put this equals to 0, I get the 25th equation. So, I can solve all those 25 equation. So, what we do is we sum them up, divide by 24 again. So, sum it up, sum this up, divide by 24 and come to this sum of this equation equals to 0. That is what I add, because all swing will be equals to 0, plus minus all swing, sum of all the plus, this plus. So, this area and this area is same. So, if I sum it up for all 24 hourly cases, swing will be equals to 0. So, tit sum up for 24 hours, for 24 hours that must be equals to 0. So, if I put that into the equation, I get the 25th equation. So, that is what we do. Let us see how we do it. So, this is sum up for 24 hours. So, this will be 24 constant, because this is delta t is constant all the time. This I sum up, and this also I sum up. Now, this is what I do for 20 t swing, this will be equals to 0, because ai I can take outside and tit swing is equals to 0. So, this term is equals to 0 and that gives me the 25th equation. So, therefore, that gives me the 24 equation. Au delta t, if I divide by 24 everything, I get it qx bar. Qx sum for 24 hours, qx bar is equals to au delta t 1 by 24 cv delta t into delta t into cv. So, delta t is constant, this cvt sum up for 24 hours divide by 24 gives me the average cv, mean cv, this gives me the mean cv, this divided by 24 will give me mean cv. So, mean cv into delta t plus cv t into ti swing summed up for all 24 hours divided by 24. So, these 24 values you can calculate out, So, if you write it further, qx would be equals to delta t. So, total heat coming in is equals to delta t au plus cv bar, because this is cv bar, delta t I am taking common. So, sigma au plus cv bar, and this is 1 by 24 cv t ti. So, this 24, every time this coefficient is different, I will have 24 different coefficients for each hour. So, I will have this equation you make it for 24 hours, you get it for 24 hours, because this you get it for 24 hours. For the 25th equation you will get it, this is the 25th equation, and 24 equations earlier I said. So, total 25 equations you will be getting, and you can solve for all those 25 equations, and you can find out the swing at every time plus the mean. So, 25 equations, 24 equations, because cv varies at every hour. So, for each hour you will get one equation. Additional equation you get by summing all of them up and dividing by 24. that is just simple algebraic manipulation, and putting ay sigma tit equals to 0. So, eliminating one of the terms, that becomes another independent equation. So, that is how we can calculate out. One more thing, supposing my inside temperature is constant and I want to find out the amount of heat to be removed, at every hour, I can do the same thing. If the Cv is constant, explicitly for every hour I can find out, because my Tit is now equals to 0 if inside temperature is constant. Conditioned building for all time, every time Tit swing will be equals to 0. So, I do not have to, I just calculate out, sum up all the heat coming in, because inside mean is known to me. Inside mean is the constant temperature that I am maintaining. So, if you are trying to find out the energy load or energy that is to be removed, heat that is to be removed or to be supplied, that you can simply find out. If Cv is constant, explicitly for every hour you can find out using the same procedure. Here we used the same procedure to find out the fluctuation, mean and fluctuating temperature inside. But if my inside temperature is constant, every hour you sum up all the heat gain, taking time lag into account, no admittance is required anymore, only the all heat gains you can sum up, and that will be the energy load into the room at that particular time, that is to be taken out. How much is your AC capacity? That will be something more, that is different, we are not looking into that. It is only how much is the heat coming in, that is what we are looking into, right. So, that will be somewhat different, that would depend upon, because how much is the capacity of the, how much is a air conditioner actually consuming the energy, that would depend upon the process of air conditioning also, supply air temperature, because it would supply the air, that will absorb it, that is separate issue altogether. So, we are not looking into this, but what we said is you can calculate out explicitly every 24-hourly energy to be removed or supplied, that you can calculate out. It is the same procedure. But if it is part of the day, it is conditioned and part unconditioned, then you calculate out for part of the day the energy required to be supplied, and rest of the time it will attain some internal temperature naturally, In that case, this 25 equation comes out to be handy to us. We use the same 25 equations in the same manner, because now for certain period of time my Ti is known, for certain other period of time Ti is unknown. So, I got to solve for those hours, I got to solve for those hours. So, I can do it. So, that is with addition of time dependent plant load. So, if I want to find out time dependent plant load, so same thing, supposing I have a plant load, same Qx that I talked about, I add Qp to it, and that must be equals to same, right, and Cv is varying now, Cv is varying, right. Okay, even Cv is constant, does not matter, but then you can simply find out if Cv is constant, then simply you can find out Qp. But if Cv is varying, then this becomes the equation, and you can actually separate out this part as Ti bar minus Ti bar, etc., etc. You can write like this. This is the mean outside. I have just added and subtracted each one of them, because for some hour the temperature would not be known to me. For on position Qxp's are unknown and inside temperature is known, because supposing my office starts at 9 am. So, I might put my air conditioner on, there are various control system, but let us say it is a simple 2-point off on control switch. So, what I do, I come to my office or somebody comes to the office, puts it on around 8:30, because there will be an inertia of the system, it will require some time to reach the temperature. So, puts it on and puts it off around 5 p.m. right. So, time of operation is known to me, and during the time it is on operation, Qx the on position when it is on, this is my unknown. this is my unknown, and when it is off position, then these are my these are my unknown, and this is always my unknown, because now part of the day temperature will be constant inside. During the other period of time, temperature is changing. So, the mean temperature will be mean of both together, sometime constant, sometime varying. So, mean would be sum total of all the constant multiplied by the hour during which it is constant, plus those time when it is not constant. So, mean it will not be a fixed value, you have to find it out, it will depend upon the inside temperature. So, mean is also unknown. So, this part is also unknown, sometime this is unknown, sometime this part is plant load is unknown. So, it would be again I set up same 25 equation QPT etc. This becomes unknown for certain period of time, and I can write that inside for some period of time inside constant temperature minus outside TO bar, separate this out for certain period of time. So, this is the constant temperature inside delta T minus TO bar. What I am doing is I am saying Ti swing plus T bar is TCT. Sometimes this is constant, sometimes this is varying. So, for constant time I can write an equation of this kind. When plant load I have to calculate out. For varying point of time, for varying time what I do is, for varying time, for off period my equation would change somewhat, for off period my equation will change, because then there is no QPT, plant load is 0, but this is unknown, this is unknown, this is unknown, etc. So, thus 25 equations of the similar kind that we had, and 25th equation we get in the same manner as we have done earlier, because the mean temperature, some total of swing temperature would be again equals to 0, because sometime it is varying, sometime it is constant. So, the mean would be above the constant, like for example 25 degrees centigrade if I am maintaining during the condition time, but other time it will be 26, 27, 29, 30 whatever it may be, or maybe 19, 18 early in the morning. So, mean temperature is not 25, it is 25 into let us say 8 hours or 12 hourly operation, say 10 hourly operation. So, 25 into 10 plus the 14 additional 14 hours I have 14 different temperature. Sum of all those 24 divided, sum of all of them divided by 24 is the mean, which will be maybe higher than 25 or lower than 25, and swing is above that temperature. So, you see the sum total of that swing again will be equals to 0. So, that is 25th equation I get in the same manner, and I calculate out the plant load. So, when variable ventilation plant load you find out same, again you are summing up everything, and 25th equation you are getting, and in the same manner as before applying following condition. This is the condition I apply, that sigma ai this should be equals to 0 during off period as well as on period. The temperature swing inside, because this is mean minus outside. So, this is nothing but T inside constant temperature, right. So, this is the inside temperature swing during the constant period, swing above the mean, the difference between the mean. TO minus delta T is the inside mean minus TIC, this is the swing in temperature during the on period. This is the swing in temperature during off period, and total swing this and this multiplied by AY, they must be equals to 0, because swing will be positive. I am calculating the mean in that manner. So, sometime my temperature will be higher than the mean, some other time it will be below the mean, sum total will be equals to 0. So, my 25th equation comes in the same manner as before, and just I remove that from the sum total and I find it out the 25th equation in this manner, and solve for this, solve for the matrix that would generate 25 by 25 matrix, perhaps it is here somewhere, and 25 unknowns can be solved from 25 equation. So, that is what it is. Now, you can't do it by hand calculation, obviously you can't do it by hand calculation 25 by 25 matrix, however sparse it is quite difficult to do that. If you remember, the good old days. I mean, it's there in, again, Engineering Mathematics, Arvind Krejcik's book. If you see the matrix chapter of the matrix, it will say 3 by 3 matrix, because you have to go to 2 by 2 determinants, 3 of them calculate out, or inversion. If you do by standard way of inversion, somewhere by 30 by 30 or 25 by or 30 by 30 matrix, maybe even lesser than, I don't remember, takes 25 years by hand calculation. So inversion, obviously there are other techniques, Gaussian elimination and all that you can do. Inversion, that takes much lesser time, right? That takes direct calculation from the matrix will take a very long time. But even doing a Gaussian elimination of 25 by 25 equation will take a long time. Or there are several advanced inversion techniques. It's very easy to do it in a MATLAB or even in Excel. Excel gives you matrix inversion. So consider this example, same room. You know, earlier for constant exchange, now I have time in hours, and I values are given. Outside temperature, air temperature is also given, right? Now the n values are given. N values are given 6, 8, 10. You know, this is the air changes. So variable ventilation rate. Variable ventilation rate, 6 am, 1 hour, 1, 1, 2, 2, 2, 2, 2, etc., etc. So variable ventilation rates are given here, in addition to the data that we had earlier, right? So you actually got to calculate out n is known, Cv. So n into room volume was 90 meter cube, I think, 6.5 into 3, 6 into 5 into 3, 90 meter cube was the room volume. So 90 by 3 into 1 is 30, 90 by 3 into 2 is 60. So Cv values are obtained accordingly. Cv values are obtained accordingly for all the hours, right? So Cv values are obtained accordingly, as you can see, Cv values are obtained accordingly. And then UA sum is this, sigma AY sum, this we calculated earlier. You know, for previous, remember this we calculated for even mean calculation, UA, this we did for calculating 6 p.m. temperature. We divided by 466.8, you know, 1268, this is how we did. And I am setting up the equations now. So 1281, this was there right earlier even. And now if you calculate out Cv into TOA, Cvs were known to us, and outside temperature is 20, 32, 34, etc., etc. Cv into outside temperature, that is what we are calculating. This will go into the heat gain. You know, to find out every 24 hourly temperature, this will go into the heat gain side, right? Heat gain side. And TOA 24, so Cv values are there. Now let us see what are those 24 equations, 25 equations are. So if you time QFC, QFS, QES at every time, I am calculating, because radiation is changing. Radiation is changing, so QFS would change. Temperature is changing, so this will also change. You know, temperature will change, you know, it's changing, so it will change accordingly. How is QFC found out? Outside minus, you know, all the time lag and all that taking into account. So this is what results in for those 25 by 25 matrix, 25, but you have to do it yourself, otherwise you won't get it. There may be some error in this, and you know, this is what finally results in right hand side of the matrix, in which TIA, you know, these terms won't be there, TIA, T terms won't be there. That is the right hand side of the matrix, and this comes out to be this, and sigmas UA Cv etc. comes out to be this 116.7, all right, and the 25 equation that comes out would look like this. You have to do it yourself, otherwise you won't get it, because it's impossible to do the whole thing here in a class, especially in a class of this level. So finally 25 equation turns out to be something of this kind. some of those equations I am just showing, and the matrix 25 by 25 matrix looks like this. So, delta Tm, Ta 1, 2, 3, etc., 10, these are my unknowns, 25 unknowns. Here it is 12 because I have taken 2 hourly temperature. So, I have 13 unknowns. 13 unknowns, 13 equations, and you can see a lot of them are largely diagonal matrix, but there is one full column, this one full row. So, it is largely diagonal matrix. If it was just diagonal matrix, you could have implicitly solved them, explicitly solved them, but then this would need doing a little bit of thing, but inversion of the matrix is pretty simple. And if you do that, you get delta Tm is this, and this is the swing in temperature. 31 minus 1.19 will be the temperature, first temperature, that is I think must be 6 am, and so on and so forth. So, this is how we can find out the inside temperature, but this is how the matrix should look like, and you have to obtain that matrix. This example you can try it out and see if this is correct. There may be some mistake, do not take it for granted, you solve it out yourself and then get it. So, that is how one can obtain the inside temperature, and even cooling load for fluctuating ventilation condition, right. So, with this we can now look into thermal comfort. With this we can look into thermal comfort actually. So, so far we talked of how to so far we have said that how you calculate out the inside temperature, right. We built it up from the beginning. First look into climatic features, various types of climates, and as I said, thumb rule can be used there. But then if I want to do a design, I should be able to find out for a given outside condition how much is the heat gain or what is the inside temperature. Supposing my objective function or my objective could be to minimize the inside temperature in a tropical summer situation during summer, and that is what we are looking at. And if it is cooling load or energy load, I would like to minimize it. So, for that I need to calculate out first, and for various options, and choose that option which will give the minimum. Now, this optimization procedure is separate, that we will talk about later on, So, that we can talk later on, but now we can look into thermal comfort. So, you can look into thermal comfort, right.